All right, so what we're going to do right now is we're going to talk about the steps for graphing a parabola. There's a lot there, but if you just remember the steps and you're able to follow the sequential directions, it's really not that bad. Okay, so whenever I ask you to graph a quadratic function, whenever I ask you to graph a parabola, the first thing you need to do is you need to find the vertex, and I need you to find that axis of symmetry that we keep talking about. If you have these two things, the rest becomes a lot easier. Okay, you're going to graph those two things on your coordinate plane. Okay, then you're going to pick two other inputs and find what their outputs are. You can pick whatever inputs you want, but typically there's easier numbers to plug in than others. You should usually make one of those inputs the y-intercept. Okay, then you're going to graph those 2 points. Okay, so I've always talked about, or I talked about in the previous video, that whenever you make a parabola in this class, I need to see 5 total points on your graph. Okay, so at this point you should have the vertex, and then you should have any 2 points that you want. And then once you have those 2 points, to get your final 2 points, all you need to do is reflect those 2 points across the axis of symmetry. Okay, it'll make more sense. We have the picture, and then you connect all of your dots with a smooth curve. Okay, so it says, for example, when it says find the vertex, the axis of symmetry, and the y-intercept, and then graph the following quadratic functions. Okay, the first one we have here is we have f of x, it's another way to write y, equals x squared plus 4x plus 3. Okay, and we got these nice little spaces here. The first thing we're gonna do is we're going to identify what a, b, and c are equal to. Okay, so a is always the first number you see that's in front of the x squared term. Okay, the number in front of the x squared term, you don't see anything, so it's just an imaginary 1. For b, it's the second number you'll see. In this case, it's a 4. And then c is always the constant. In this case, it's a positive 3, because it's plus 3. Okay, so let's go through my steps. The first thing I'm going to do if I want to graph this parabola is I got to find the axis of symmetry. I'm just going to call it AOS. Okay, to find your axis of symmetry, it's going to be this formula every single time. X is equal to negative b over 2 times a. So for this particular example, let's plug the appropriate numbers in for b into a. So my numerator should be negative b, in this case it should be negative 4. And then my denominator is going to be 2 times a. In this case, a is equal to 1, 2 times 1. Simplify this a little bit, it should be negative 4 over 2. And then what I should end up with, negative 4 divided by 2 is the same thing as x equals negative 2. Okay, this is my axis of symmetry. It is a vertical line that cuts the parabola in half. So what I'm going to do is I'm going to draw a dotted line at negative 2. Okay, I haven't sketched any part of my parabola yet, but I know this is the imaginary line that's going to cut the thing in half. Okay, so I found my axis of symmetry. I know it seems like a tedious step, but it's going to help you long term. Okay, after you find your axis of symmetry, you're going to find the vertex. Okay, it's either the top of the frowny or the bottom of the smiley. Okay, your vertex is always going to have an x coordinate and it's always going to have a y coordinate. And your vertex is always going to be somewhere on top of this dotted line that you drew right here. It's always going to be somewhere on the axis of symmetry. Okay, now here's how you find your vertex. Your x coordinate for your vertex is always going to be whatever this number was right here. Okay, I'll call it negative b over 2a. Then your y coordinate is going to be whatever you get back after you plug in this number into your original equation. Okay, it's going to look a little bit weird how I write this, but the mathematical way to write this is if you want to plug this number into that equation, what you get back is f of negative b over 2a. Okay, this looks super ugly, but here's all it is. Your x coordinate is whatever that number was for your axis of symmetry. In this case, it's negative 2. Okay, to get your y coordinate, all you have to do is you have to plug this number into this equation. So we'll do it. Calculator can be super helpful here, but if I want to do this by hand, it's the same thing as -2 squared plus 4 times -2 plus 3. Okay, -2 squared is 4, minus 8 plus 3. 4 minus 8 plus 3 should give you, I believe, -1. Okay, calculator can be super helpful, but I just did it by hand. Okay, so to recap, what did I do? To find the bottom of your smiley, I know it's a smiley because A is positive. My x coordinate is whatever number I got here, and my y coordinate is whatever number I got after I plugged this number into this equation. In this case, it's -2 comma -1. Okay, so I'm going to graph that point, and I'll change the color. -2 comma -1. Okay, so what I just got is I got my first point on my parabola. I got the bottom of my smiley. Now, I got to get basically 4 other points. So I got to figure out what are the easiest numbers to plug into this equation. Now, here's my process. I got to figure out what I want to plug into this equation. The easiest number to plug in is usually the first point to the right of your vertex. Okay, so I already plugged in -2 into this equation. To get my second point, I'm going to plug in the first point to the right, which would be right here. What is this x value right here? I'm going to plug in -1. So I zoom out a little bit. Let's plug in -1 into this equation. Graph and calculator can be super handy here. Okay, when you plug in -1, you got to do a little bit of math. You could use the graph and calculator if you like, but if you guys believe me, it should spit out a 0 after you plug in -1 to that equation. So I plot it. -1, comma 0, which is right there. Then I got to get one more point to the right of my axis of symmetry. Okay, but I always want to have my y-intercept, as I talked about up here, and my y-intercept is always just going to be the coordinates, 0 in for x, and then whatever c is equal to. In this case, c is equal to 3. 0, comma 3 is the third point that I'll have, and I graph it. 0, comma 3 up here. Okay, now here is the #1 time saver. Let's look at our graph a little bit closer. So I have 2 points to the left of my axis of symmetry, but what I know is parabolas are always able to be cut directly in half. Now, to get my 2 other points, rather than going through that tedious process of plugging numbers into that equation, all I have to do here is I just have to reflect these points over my axis of symmetry. So what do I mean by that? I know if I'm 1 unit to the right of my dotted line, I'm at 0. So to get my second point, all I have to do is I have to go the opposite direction. If I go 1 unit to the left of my dotted line, I should be the exact same height, which is right here. Without doing any sort of math, I got another point. Then I do the exact same thing for this point up here. Okay, when I'm 2 units to the right of my axis of symmetry, I'm way up here. So to get another point, all I got to do is go 2 units to the left, and I got another point right here. I'm reflecting it over that imaginary dotted orange line. And then once I have all those points, I play connect the dots, and I have my smiley. Goes up forever and ever, and this is my vertex.